Welcome. Let's take a look at number 2. Here are the ages for 19 math professors at a university. And you'll notice I did put the data in order for us, so they are sorted. And we'd like to check the professors here to see if there are any ages that would be considered math professors that are outliers. And then we will construct the modified box plot. All right, so I have 19 values, so let's find our median first. So the middle of that list, I'm just going to take 19 here, divide that by 2, so that's 9.5. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, then that value, 48, would put me in the middle of that list. So I would have 9 numbers to the left of it, 9 numbers to the right of it. So we have our median Q2, the second quartile. And then the middle of the values to the left of it would be the 43. So there's our first quartile. And then the middle of the 9 numbers to the right of Q2 would be 53. And that is our third quartile. All right, so in order to check for outliers, we need the IQR, so the difference between the third quartile and the first quartile. So in this case, 53 minus 43 is 10. And then we'll find our boundaries. All right, so I'm actually going to switch colors here. So the boundaries are not data values. They are just tools for identifying any professors that might be outliers. So our lower boundary, we take our Q1 and subtract 1.5 times our IQR. And our upper boundary, we take our third quartile and add 1.5 times the value of our IQR. Okay, so in this case, our lower boundary is 43 minus 1.5 times 10. Our upper boundary is 53 plus 1.5 times 10. All right, so now that I have those, I'm going to come over to my calculator and type 43 minus 1.5 times 10. And my calculator knows order of operations, so it would do that multiplication first and then do 43 minus that product. So you can just type it in directly, and that gives me 28 from my lower boundary. And then my upper boundary, 53 plus 1.5 times 10, gives me an upper boundary of 68. All right, and then we're ready to see if any of these professors are outside of those two values. So let me put them on my picture here. So let's start with our lower bound, 28. So here's 26 and 34. So 28 is between them. So there's our lower boundary, 28. And our upper boundary is 68. So that would be between the 64 and the 70. There's our upper boundary. $68. And it does indeed look like we have outliers. So let me go back to my other color here. So the data values, 26, I'll put a little asterisk there. So that's below the lower boundary. So that one is outside of the boundaries. And then on the upper end, the 70 is a data value that is also outside of the boundaries. So those are our outliers, which we will graph. So let me just make a note then of my outliers. So 26 is an outlier as well as 70. All right, so 26, 70 are outside the boundaries. Just to have an explanation here. So outside boundaries. So they will not be part of the whiskers. So we do want to think about where our whiskers will be. So the left whisker will be the lowest value inside of bounds. So if 26 is an outlier, the next lowest number is 34. So that will be our left whisker. And then on the high end, ignoring the 70 because it's an outlier, the highest number, ignoring the 70, is 64. And so that gives me my right whisker. Okay, then we're ready to graph. So I'd like to do the box first. So 43 is my Q1. 53 is my Q3. So the first and third quartiles make up the box. And then the median Q2 was 48. So the box is actually perfectly symmetric at this point. Let's put the whiskers on. So the left whisker ends at 34. The right whisker ends at 64. All right, sorry, that line didn't look too straight there, but there's my other whisker. So this graph is appearing basically symmetric. But then we will go ahead and identify our outliers. So my professor down here that was 26 years old would be marked with an asterisk. And then my other professor on the higher end that is 70 years old would also be considered an outlier among these 19 professors. Right, there you go. That's a modified box plot. We identified the outliers. All right, so the next one, I'm going to go ahead and take a little bit more advantage of technology. So first thing to point out is that we have a bunch of data here. These are scores for 25 students that took an algebra test, and the data has not been sorted for us. So we basically have the raw data. So if you'd like to pause, what I did was put that into my list. So stat edit. And I went ahead and entered the data into my L1. So it's not necessary to sort it in order to find the values associated with what we're looking for, but it will make it easier to look for our whiskers and such by sorting it. So I just put it in L1, and then I'm going to sort that list. So I'm going to do stat. Second choice there, sort, and I'll put it in ascending order. And I'll tell the calculator L1, so second one, L1. I want to sort the data in list one. Hit enter, it says it did it, done. So just taking a look again, I can now see that that data has been sorted. And if I scroll to the very top here and highlight L1, I'm going to hit enter, and I can see that list now sorted across the bottom. Okay, so rather than looking for the quartiles myself, let me take advantage of one var stats. So I hit stat, calculate one var stats, hit enter. And if I scroll down here, I'll see the 5-number summary at the bottom. So the 5-number summary, it does state the minimum, but again, that might be an outlier. So we don't want to worry about that. We just focus on Q1. So that one is 34.5. The median, which is Q2, 45. And then the Q3, third quartile, 56.5. All right. And I'm just going to go back to my home screen here. I hit clear, and let's find our IQR. So Q3 minus Q1. So 56.5 minus 34.5, writing a little small here because I'm going to run out of room. 56.5 minus 34.5, the difference of 22. So then I'm ready to find my lower bound and my upper boundary. I'm going to switch color here. So again, These are not going to be student scores. The boundaries are just tools for identifying outliers. So lower boundary is Q1 minus 1.5 times the IQR. Upper bound is Q3 plus 1.5 times the IQR. So I just like to write both formulas to be careful I get them correct. Q1, Q3 there, and then minus and plus. And then we can do our substituting. So Q1, 34.5 minus 1.5 times my IQR. And for the upper bound, it's Q3, 56.5 plus 1.5 times my IQR. All right, now I can type each of these in. So I will do my lower boundary first. And I didn't think that looked right. I typed that wrong. Let me try that again. 34.5, I missed a decimal, minus 1.5 times 22 is 1.5. And then my upper boundary, 56.5 plus 1.5 times 22 is 89.5. All right, so then I'm going to go back to my sorted list. So I'm going to go back to stat edit. And I'm looking for any numbers that are below the lower boundary. But let me go to the top here, L1, just hitting enter. You can see the bottom. The smallest number is 13. So there are no numbers below 1.5. So nothing on the lower end that would be called an outlier. And then as I scroll over to the end of my list, my highest value there is 100. So that's bigger than the upper boundary. So 100 is out of bounds. And then we have an 81. So my upper boundary, 89.5, would be right there, putting the 100 out of bounds, making the highest number in the bounds the 81. Okay, so I have 100 that's out of bounds. And let me go back to my purple color here, because this is a data value that we will graph. So, oops, sorry, getting used to a new computer here, taking me a little while. 100 is an outlier because, so I'll be more specific. Instead of just saying out of bounds, I'll say it is because it is above the upper boundary. So that's what puts it out of bounds. All right, so for my whiskers, there was no outlier on the lower end, so the left whisker is the smallest number in the data set. And then the right whisker will not be the 100, that's an outlier, so instead will be the 81. All right, and then we're ready to graph. So just approximating here, it does not have to be perfect. I'll do my Q1 first. So 34.5. Yeah, I'll go there. Good enough. 34.5 and 56.5. Mm-hmm. All right, good enough. So there's the box part of my box and whisker diagram. 45. Actually, we have another box that appears symmetric here. And then let's get some whiskers going. So the left whisker is at 13. My right whisker is at 81. Still appears reasonably symmetric. But then we did have a student that scored 100. And so among these test scores, scoring 100 is considered an outlier. So quite far above the rest. And we do our asterisk there for our outlier. All right, and then I'll end this one with just graphing it here on the calculator. So if you want to check out the video on learning to graph it, I've set the calculator up already, so I'm just going to hit graph. So there's the graph. I'll hit trace and just confirm my answers are correct. So my median was 45. I'll go to the left. Q1 is 34.5. My minimum value, that's my 13, that's the whisker. And then coming over to the right, calls that value X, 81, because it's not actually the maximum. It just happens to be the end of the right whisker. The maximum was 100, and that was our outlier. All right, and there you have it, modified box plot.